Number one, what are my 2 points that I'm going to start out with for my base graph? 1 comma 0. There we go. Not quite exactly the same thing as point. And 6, 1. Where do we get the 6, 1 from? The base. Okay, where's my asymptote to start with? X equals 0. Where are we going to be moving that graph? Say again, I'm sorry. Good. Right 2, down 1. Remember, to get right and left, it's got to be in parentheses or grouped with my x. So if there's no parentheses, there's no right or left movement. So always set it equal to 0. In your head or on paper, doesn't matter. But that's a positive 2, so that's a right 2. And then we've got the minus 1, which is down 1. Okay, so I'm going to show the base graph. We're dealing with an integer 6. So when I do my 1, 0 and my 6, 1, I'm coming along here and then going down next to the x-axis. So there's the base. But then I need to move that graph right 2, down 1. So each point, right 2, down 1. Right 2, down 1. Whoops. So where does my asymptote move? X equals 2. Good. So what a lot of people like to do to help themselves is actually draw that line in. So if I draw the line x equals 2 in, because I was moving right 2, then it makes it easier when I go to draw in my curve to know what I can't cross. You have to draw the asymptote? No, but don't cross over that line. So whether it's drawn or not, don't cross x equals 2. So my asymptote would be at x equals 2. What would my domain be? Greater than 2. Good. What would my range be? All real numbers. Because now your asymptote is on x, a vertical, so it's everything to the right of that line. So the greater than 2 is for your domain. Where for exponential growth and decay, the graph was the other direction. It was up or down for moving our asymptote. Then it was our range that changed based on our asymptote. All right, so here, what are my 2 points? Why 7, negative 1? Good. Remember, we had a decay graph if we went for the inverse, 1/7 to the x. When we graph decays, we always said it's easier to deal with that negative power, so we'd flip our fraction. So we take the 1/7 and flip it over, make our y the negative 1, because a negative 1 exponent would flip that fraction. Asymptote at 0. Where does it need to move? Up 1. Good. Okay. The plus 1 is not in parentheses, so then it can't go right or left. It just goes up. So if I do my base, 1, 0, 7, negative 1. Remember, it's now, because that was a 1/7 there, inverse of a decay. There's my base. And then I'm just taking those points up 1. So is my asymptote moving? No. Well, it doesn't curve up. Sorry. So my asymptote stayed at 0, or x equals 0. Where's my domain? X is greater than 0. And what's my range? All real numbers. Good, because we're getting all the y's back. Yeah. No. If you can do that all in your head, I'm good with that. I will tell you on a quiz that I do kind of give a point for the work. So if the graph is wrong, with nothing written down, you're going to lose probably 2 points. Where if you wrote down the right stuff and graphed it wrong, it'd be 1. Or you wrote down the wrong thing but graphed it according to what you wrote, it'd be 1. So you'd lose more points for not writing it down if you get it wrong. Make sense? Okay. All right, change of base formula rounding to 3 decimals. What is the change of base formula? Log of the 1/6, log of the 8. So if you remember from yesterday, log base A of C is log of C over log of A. What base am I changing it into? What base do both of these have? What base? 10. So you've changed it, the change of base formula changes it into a base your calculator can deal with. There we changed it into base 10. I could also write ln of 1/6 over ln of 8. What base would I then be changing it to? Natural log, what's the base? Somewhat important to know this. Look on your notes. E, absolutely. So log base E is the same thing as natural log, or ln. Either way you do this, what do you get back? Negative 0.862. Okay, so what are you going to do for the change of base of log base 4 is 64? Good. What do we get for that? Could you have done that in your head? Why? What are you finding? 4 to the what power gives me 64. So if you go back to the way we did it the first day, we would have done that and said 4 to the y equals 64. What power do I have to take 4 to get to 64? I have to take it to the third, or cube it. Okay, so you can do these things multiple ways. It's problems like, what power do I take 8 to get to 1/6? That one you don't know off the top of your head. You need your change of base formula. Yes. 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 You flip the fraction. Right, because in order to flip that fraction, to flip the 7 up to the top, you would have needed a negative exponent. So we do a -1 for our y value there. Okay, good on that stuff. So what we do today is take our properties of exponents and apply them to logarithms, and then expand and condense logarithms based on those. So remind me, what do we do when we multiply a to the 5th times a to the 7th? What do we do to our exponents? Add them. What if we divided a to the 5th over a to the 2nd? What would we do? Good. What about if I'm doing power to a power? What do I do with my exponents? Multiply them. Good. What happens then with logs is we use that same basic concept. The product property for logarithms says if I'm taking the log base b of m times n, I take the log base b of m plus the log base b of n. So I'm multiplying m and n, I add their individual logs. If I'm dividing m by n, I take the log base b of m minus the log base b of n. And if I'm multiplying, or I'm sorry, if I have a power property for logs, log base b of m to the n power, I take that n and I multiply it out in front. So when I'm multiplying, I'm adding. When I divide, I'm subtracting. When I have a power, I'm multiplying. So exact same process we did with exponents, we're now doing with logarithms. Why do we do it? To be able to expand them into multiple statements so that we can simplify, or take them back into one statement, which is an easier one to simplify. So when I look at a problem that says expand the expression and I look at log of 2x, I got to say to myself, what's happening in that of part? Log of whatever. What operation's happening here, the 2x? So if I'm doing multiplication there, I need my product property because multiplication gives you a product, which tells me that I add the individual logs. So this is going to be log of 2 plus log of x. What's my base in both of those situations? 10. Good. And then I'm done. I can't go any further. 2 and x are simple. There's nothing to simplify about them. Okay, so then when I have log of 3/4, what's happening in the 3/4? Division. Well, division, when I take two numbers and divide them, I get a quotient. My quotient rule tells me to subtract the individual logs. So I would take log of 3 minus log of 4. No. Okay, log base 5 of 2 to the third. What's happening with the 2 to the third? I don't worry about the base. I'm worried about what happens in the of part of my statement. Okay, when I deal with a power to a power, I multiplied. Here I've got a power in my logarithm. I multiply. That power comes out in front times log base 5 of 2. So you just take the power, throw it out in front, and you're multiplying. Does that make sense? Okay, so then those were simple examples. One thing happened in each one. But we can expand when multiple things happen. For instance, log base 8 of 5mn. What's happening in the of part? What's happening here? Okay, so if we're multiplying, what are we going to do to the logarithms? Add them. So we're going to have log base 8 of 5 plus log base 8 of m. Perfect. Plus log base 8 of n. Okay, log base 4 of 8x over 3. Adding and subtracting, because here we're multiplying, but we're also dividing. So we're going to have to add to show what's happening in the numerator, and we're going to have to subtract to show the division. Okay? What I tend to do with these is whenever things are grouped together, like the 8 and the x are grouped in the numerator together, I put parentheses around them. Do you have to when they're in the numerator? No, because we read these left to right, so we would multiply them first anyways. But if they're in the denominator, you have to. So that's why I just do it as a general rule of thumb. If they're grouped together, I put parentheses around it to group them together when I expand. That way I don't have to remember, should I do it now or shouldn't I? I just always do it. So here, I'm going to have the log base 4 of what? And then what? Good. Good. Plus log base 4 of x. Those two are grouped together now in my parentheses. Dividing tells me to do what operation? Subtract log base 4 of 3. Perfect. Good. Okay, what two operations are happening on this ln of x, 8x to the third? Multiplying, and then we've got a power. So multiplication gives me adding. What is the power on? It's on the x. So the only one that's going to get that power out in front is the one with the x. So what do we do between the 8 and the x? Because we're multiplying, we're going to add. So we're going to have ln of 8 adding, but now that power is on the x to the third. So where's the 3 go? Out front. So 3 ln of x. If you were simplifying a problem without an ln in it, yes, you would do the x to the third first. But because it has the log there and we're expanding it, you don't do that first. Right. You just kind of read it left to right. We okay with that one? Okay. So we're expanding log base 2 of 3y squared divided by 4. So what's going on in the numerator? Multiplication and power. What's going on overall? So we are going to have all of the rules in one problem now. Where do we start? Okay. Log base 2 of 3 plus 2 log base 2 of y. And I want to group those together. Subtract log base of. Okay. Now, I'm going to tell you what your book sometimes does. I like that answer because I know I can go from that answer back to my original. The book sometimes likes to give answers to parts of the problem because you can simplify this. If I change this to exponential, just that part, I would be saying 2 to what power gives me 4? So I could put a 2 there and have log base 2 of 3 plus 2 log base 2 of y minus 2. I personally prefer the top one because I don't have to do as much work to get back to my original statement. But oftentimes in the back of the book, if you're looking at answers, they will do something like write the 2 there. Or if it's log base 2 of 2, they'll write a 1 there because 2 to the first gives you 2. Okay, so I just want you to be aware when you're looking in the back, if they give you just a numeric number there, they give you a number as part of your answer rather than a log, look at the statement and say, base to what power gives me that number? And that'll tell you if you are in the same spot as what they were. Does that make sense? Okay. All right, log base 7 of x, the square root of x. Perfect. So this is the same thing as log base 7 of x to the 1/2. So when it's in radical, change it to rational, because then we can use our rules. So how is that going to expand? Perfect. 1/2 times log base 7 of x. Does that make sense? Everybody understands where the 1/2 came from. Okay? When we are dealing with radicals, to change to rational, the number that's by the x is my numerator. The number that is outside the root is my denominator. Good? Okay, because here I need to expand the ln of the 5th root of x squared. So same process, what does this look like as a rational? Which one goes on top? 2 over 5. Number with the x on top, the root goes on the bottom. Okay, now I can expand it. Perfect. 2/5 ln of x. Good? Right? Now we're going the other direction. We're condensing. So we're given the long drawn out statement. I want to take it back to one statement. So I only want to see the word log once or the ln once. I don't want to see it multiple times. So then you got to do the same process we started out with on the other one. Look at what the operation is. So I have subtraction there. So it's division. So what are we going to have? Log x over 3. What's the base there? 10. Do we have to write it? Perfect. We do not. Okay, log base 10 of 2 plus 2 log base 10 of x. You don't have to write the 10. Where does the power go on? On the x. Multiplication, because we're adding. So I was hearing multiplication out of people, so you're right. Log base 10 of 2x squared. And the squared only goes on the x because the 2 is only with that log base 10 at x. Yeah. Log is base 10 or any other base. Like here, these were both base 10. ln is the base of e. So if I wrote out log base e of 5, this could be written as ln 5. It's just a special notation for whenever we have a base of e. Yeah. So like if you had 2 log base 10 of 4x, then this whole thing would get the power. So this would move to there, but the 4x would be in parentheses. Then I would multiply, so like this. Then I would be taking log base 10 of 2 times 4x squared, which I can simplify because that's 4 squared and x squared. So that's 2 times 16x squared, 32x squared. It's the same exact process we just went through. We just could simplify because you know how to square 4x squared. You know how to do that. Does that make sense for the questions you guys were asking? Okay. Good questions. All possibilities that could come up. All right, log base 3 of 2 minus 1/2 log base 3 of y. What's the minus? Becomes division. What about this 1/2? Exponent. Over y to the 1/2, yes. Yes, you could. Log base 3 of 2 over square root of y. Also the same. Good? All right, log base 5 of 14 minus log base 5 of 4. Log base 5 of 14 over 4. Can we reduce? Yes. 7 over 2. So when you have the ability to simplify in a problem, you should simplify. All right, log base 7 of 8 plus log base 7 of x plus 2 log base 7 of y. Eight xy squared, because we have a power. Okay, so both of the pluses give you multiplication. So that's why it's 8xy, but then that 2 has to become a power on the y. Good? The monster. Now, I'm going to write out every little step. You can do some of it mentally if you want to do it mentally. Okay, but let's analyze it first. What do we have involved? We got parentheses, so we're going to deal with parentheses first because that's always been our rule. But within all of it, we have division, I heard, and we have exponents. So we know we've got to divide for the 2 subtractions, and then we've got 3 different powers. Okay, so when we get to simplifying, we're going to simplify within the parentheses first. However, you could write things as powers right away if you want. So what do I know this first one's going to be? Log base 4 of, and what does 27 to the 1/3 really mean? What about the 3? What is 27 to the 1/3? What's it tell you to do? Cube root. Okay. Minus, in parentheses, we've got log base 4 of 6 squared, good, minus log base 4 of 2 to the 1/2. Okay, so if you need to see it underneath here, or instead of 27 to the 1/3, you could write cubed root of 27. What is 81 to the 1/2? Try again. Square root of 81 is 9. Okay, so we will be going to that step of actually taking the roots. So if you need to see it as a radical rather than rational, rewrite it. Completely up to you, though, whether or not you need to see that step. Okay. Do you want to simplify those two numbers first, or do you want to deal with the division? Okay. I heard division first. It doesn't matter. So we know because this is subtraction, we're dividing. What are we dividing? No, I'm not dealing with that. I'm dealing with parentheses first. I heard 36, so now I'm hearing that I want to get my numbers first. Remember, I'm writing out every step. You can jump. You can jump to the next step, but I'm going to write everything out. What is 81 to the 1/2? Okay, I'm still dealing with my parentheses first. What do I do with log base 4 of 36 minus log base 4 of 9? Make it a fraction, so it's log base 4 of. Do I need my parentheses anymore? No, because I've combined those two into one statement. Okay, now I can work left to right. What is the cubed root of 27? So I have log base 4 of 3 minus log base 4 of 4. And then I'm still subtracting, so I divide it. Log base 4 of 3/4. Okay, and again, I just wrote out every single step that we did. Do I believe that you can do some of that mentally? Absolutely. You know 6 squared is 36. Write it right away. If you know the square root and the cubed root, write them right away. Okay, you don't need to necessarily show me every single little step if you can do some of that mental math in your head. We're good? All right. Your assignment is on page 510, 3 through 6 all, 15 to 27 odd, 28 to 30 all, 3 to 41 odd, and 42 and 44. And I'm going to give you your review packet. And after you've had time to copy that down, then we will have a discussion about the rest of the week and how it will run. I just want to do a quick clarification. When you have, say this, let's do a minus there. You do not write the word log twice. It is not this. Okay? The whole point of condensing is taking it down to one time of writing that word log base 3. It's the numbers after that you write in the fraction. Does that make sense? So you want to make sure you don't write those words twice. Good?